Good morning, everyone, and welcome to the Define Tomorrow Technology Conference keynote. Today, I have the pleasure to talk to you primarily about what we are doing from a hyperconverged infrastructure perspective and how we are revolutionizing the data center, not only today, but also tomorrow. My name is Duncan, and I'm a chief technologist working for VMware in the cloud platform business unit. And my primary focus over the last couple of years has been storage and availability, but of course also the vSphere platform. What, as I've already mentioned, I want to talk about today about primarily is how we are going to architect the infrastructure going forward in the upcoming couple of years. As Barry already mentioned during his keynote, the world is slowly changing from an application landscape, and I probably shouldn't be saying slowly, because what we're starting to see is that the adoption of cloud-native applications is actually rising at an extremely rapid pace. IDC has actually done some calculations, and IDC has calculated that in the upcoming 5 years, we will be deploying more applications and services than we have done so in the past 40 years. Now, if you take that experience you had of the past 5 to 10 years and the way you went about deploying applications and virtual machines, you can imagine that if you would have a similar data center, you would leverage a similar type of data center going forward, life would be extremely complex. Key reason for it being, of course, that traditional data centers are not really suitable for the newer type of workloads that we're starting to see popping up all over the infrastructure right now. As I've already mentioned, these cloud-native workloads are a newer type of workloads, and they also require a different type of provisioning of these types of workloads as well. The current data centers are not only inefficient, they also tend to be rather slow, and that also introduces a lot of risks, not just risks from an infrastructure perspective, but also, of course, also risks from a business perspective. Because if you work for one of those companies which unfortunately happens to be too slow in terms of implementing new solutions, which allows you to sell new services to your customers, you may also be one of those companies that does not exist anymore, unfortunately, 5 to 10 years from now. Now, within VMware, one of the things that we have focused on is trying to create this newer platform that will allow us to start deploying these newer types of services as well. And I realized when I started creating these slides for this slide deck that we have been talking about these 3-layer cakes for the last couple of decades. In the past, when we referred to a 3-layer architecture or an infrastructure, we would typically be referring from an infrastructure perspective to storage, networking, and compute. From an application perspective, we will typically be talking about these different layers, which from an application standpoint would be the database, the typical middleware solution, and the web front end as well. Now, if you look at it from a cloud native perspective, again, we are talking about these 3 different layers. But when I'm talking about these 3 different layers, I'm referring to the layers of the infrastructure itself. Today, when you would deploy a cloud native workload, and it's a cloud native workload that ends up landing on a VMware platform, typically what you will be looking into is TKG, our Tanzu Kubernetes guest cluster offering. And Frank is going to explain a bit more in depth what that actually entails. That solution by itself, of course, will need to land on something. And that solution where it typically would sit on top of is vSphere plus Tanzu. And then, of course, there's the vSAN data persistence platform as well. Now, when we talk about vSphere and Tanzu, of course, that needs to run on top of something as well. And typically, that is the infrastructure layer that sits underneath, all of the different hardware components, which Barry also alluded to during his session. Now, as part of those hardware components, of course, we have the storage stack, we have the networking stack, and on top of that, we have all of the security aspects that come into play as well. In the upcoming 25 minutes or so, my focus is primarily going to be on the bottom half of this diagram. So I'll be talking about storage policy-based management and how you can use storage policy-based management to start deploying newer types of services on top of your infrastructure. Now, vSAN is one of those components that could be part of your infrastructure. I'm not necessarily saying that it needs to be part of the infrastructure, but it is one of those solutions that will allow you to not only deploy traditional virtual machines, traditional workloads in a very easy way on top of an existing infrastructure, On top of that, it also allows you to deploy cloud-native workloads in a very efficient and easy way on the exact same infrastructure managed by the exact same tools. And then last but not least, something that we've added as part of vSphere and vSAN 7.0 is the ability to also start creating file services as part of the same infrastructure. And I actually have a demo later on in the session showing you what that looks like, what we have been able to achieve from an integration standpoint. Now, when it comes to vSAN, I think there's one thing which is very important to understand, but it doesn't just apply to vSAN, it also applies to virtual volumes, which is the ability to manage virtual machines or manage containers through policy when you deploy them on a virtualized platform. As I've mentioned, this doesn't only apply to vSAN, it also applies to virtual volumes. And the great thing about this particular solution is that when you provision a virtual machine, you no longer need to specify where the virtual machine needs to reside or which capabilities should be enabled from a availability or maybe performance standpoint. Policy-based management specifically allows you to specify within a policy what kind of capabilities the virtual machines that will leverage that policy should be provisioned with. So just to give you a very concrete example, if you provision a virtual machine and that virtual machine or that application, the container, for instance, needs to be able to specify an X number of failures. In other words, 1, 2, or 3 hosts within a cluster should be able to go down without impacting the availability of the data for that virtual machine itself. You can specify that within a policy. You associate the policy with the virtual machine, and now when the virtual machine gets deployed, vSAN or virtual volumes will actually take care of all the magic at the back end. So no longer do you need to look at a spreadsheet to figure out which data store actually has which capabilities enabled. No, you can simply just select the right policy for your workload and off you go. Not only will you have the ability to do that yourself, but if you're leveraging some form of self-service capabilities, or if your developers or application owners are leveraging those capabilities, they can actually start provisioning the virtual machines, leveraging the policies that you've defined. Not only do these policies apply to things like the RAID configuration, for instance, which is something that you're able to do within vSAN, but you can imagine that this also is something that you can leverage for disaster recovery. Now, in this example, specifically on the screen, I'm actually showing you what a virtual machine or an object would look like when we deploy it with a RAID 1 configuration, meaning we would have 2 copies of the data and we will have a witness component sitting there as well. But the same mechanism would also apply to a RAID 5 or a RAID 6 configuration, or if I would have striping or any of the other typical storage capabilities enabled. As soon as I have that enabled and vSAN in this particular situation deploys the virtual machine, in the backend, vSAN will ensure that the data is distributed as was specified within the policy. And personally, I think that is one of the core strengths of the platform itself. Now, besides that, of course, when you look at vSAN, we have a lot of other different capabilities that we can enable, not just from a policy perspective, but of course also on a cluster level. The majority of data services are enabled on a cluster level. And when we're talking about data services, most of you will probably be aware of the fact that vSAN offers, for instance, the ability to enable deduplication and compression. And of course, most of you will hopefully also be aware of the fact that we already had data at rest encryption a couple of versions ago. Starting with vSAN 7.0 Update 1, we now also provide the ability to have data in transit encryption, and on top of that, enable compression only. So if you're one of those customers that doesn't necessarily benefit from deduplication, you can decide to only enable compression only on your vSAN data store. And as I've already mentioned, keep in mind that these data services, all of the data services listed here, are enabled on a per data store basis. So this is something that I think it is important to realize. Now, the other thing which I think is rather unique about vSAN is that it also provides you the ability to specify what your data center looks like. So if you have a data center that looks something similar to this, you can now specify within the UI which hosts are part of which fault domain. And this will hopefully then, when vSAN starts provisioning the components that are part of the virtual machine that you are deploying results in higher availability. Because in this particular scenario, when we would have a RAID 1 configuration where we would need 3 fault domains, vSAN will ensure that each of the components is stored in each of the racks. So even in the scenario where a single rack has failed, the data should still be available. Now, the great thing about vSAN is that not only can you do that from a rack perspective, we also provide the ability to do that from a campus point of view. Now, campus clusters or stretch clusters, as they're typically referred to as well, is something that is very common in Europe. And if you're one of those customers that has a campus that looks something like this, then vSAN typically or specifically allows you to specify in the UI which hosts belong to which building. In this particular case, I have 2 hosts in building 2 or a building 22, and I have 2 hosts in building 13. As long as the latency between these buildings is below or equal to 5 milliseconds round trip, vSAN is good to go. Now, what I think is most amazing about this particular solution, and I've implemented probably dozens of stretch cluster configurations over the past decades. What I think is truly unique about this solution is how easy it is to configure and install. The majority of stretch cluster configurations, and for those who are using a stretch cluster configuration, they can probably attest that it typically takes weeks for these implementations to be up and running. When it comes to vSAN, we're literally talking about 5 to 10 clicks, selecting the host, selecting the witness that resides in a third location, and you're ready to go. The most challenging part of implementing a stretch cluster in this particular situation is having the discussion with your network administrator and figure out if you should be stretching layer 2 or if you're aiming for a layer 3 implementation. And of course, that is something that, as I mentioned, will probably be a challenging conversation to have. Now, when it comes to vSAN, of course, that's not where we stop. The other thing that we've ended up doing is integrating a lot of the smartness into the HTML5 interface. All of you have probably seen the HTML5 interface, probably seen it plenty of time, or you've used the web client extensively over the last couple of years. And one of the things which I think is rather unique from a vSAN perspective, especially when you compare it to any of the other hyperconverged solutions out there, or even any of the other storage solutions out there, is how we've integrated the layer into the hypervisor itself and into the interface of the hypervisor as well. For instance, we provide an extensive health check that shows you what the environment is doing. Not only if something is misbehaving, but of course also if there are green checks, it's very useful to see what is happening in the environment. We've not only done that for the hosts, for the disks, for the disk controllers, but we've also done that for the network and all of the services that sit on top. Besides that, we've also introduced a lot of additional performance metrics and performance graphs as well that will allow you to do advanced troubleshooting if something is happening from an infrastructure perspective, or if one of your virtual machines is misbehaving. And then last but not least, of course, we also provide a significant amount of information around what kind of data is being stored. And in this particular example, this is actually the 6.7 U1 interface. But soon in the demo that I will be showing, I will actually demonstrate to you that we've been enhancing this particular interface as well to start including additional data that customers may be storing on top of the exact same platform. Now, I've already mentioned this. What I would like to discuss today is not only what we have available today, but I would also like to provide you some hints of what is coming up in the future. As we've already mentioned, the world is slowly moving towards these cloud-native applications. But not only is the world moving towards these cloud-native applications, what we're also starting to see more and more is that a lot of customers will have this hybrid infrastructure implemented. And with hybrid, I'm not only referring to the fact that they have on-premises virtual machines or workloads next to their public cloud workloads. But what we're also starting to see is that more and more customers are starting to deploy additional services in edge locations. And of course, whenever we see these trends happening, additional requirements start to emerge. And when I refer to additional requirements, I'm not only talking about additional storage capabilities, I'm also talking about the expectations in terms of efficiency and of course in terms of security. A lot of our customers expect the ability to not only protect the data going forward in a very efficient way, and I actually have a couple of slides on that later on, but also they expect the ability to be provided with additional data insights and data governance. What kind of data is being stored? And am I actually adhering to some of the internal policies or policies our government has provided? And then last but not least, of course, as I've already mentioned, as we are starting to see this shift from traditional applications to cloud native applications, we will also need to be starting to provide the capabilities within our storage platform that enable you to start provisioning these types of applications and storing data for these applications as well. And then last but not least, of course, you need to manage the environment in a unified way. And hopefully, we will also be able to provide you some self-driving capabilities. In other words, artificial intelligence that will start making decisions based on what is happening in the environment and based on what it has learned from other environments as well. Now, one of the first things that we focused on, and I've already mentioned this briefly, is file services. File services, vSAN file services, is a capability that we've introduced as part of vSAN 7.0, but in vSAN 7.0 Update 1, we've actually enhanced it. With vSAN 7.0, we've introduced support for NFS version 4.1 and NFS version 3, but in 7.0 Update 1, we actually introduced support for SMB version 2.1 and version 3. On top of that, we've also introduced support for authentication, Kerberos specifically for NFS, and Active Directory specifically for SMB. Now, some of you may be wondering why we are introducing file services as part of the vSAN platform. Well, one of the key reasons for us to introduce this capability is because of the fact that a lot of the cloud native applications that our customers are now starting to deploy have the requirement of storing some form of state somewhere in the environment. You can imagine that if you're one of those administrators that is now responsible for managing these cloud native workloads, you don't want to manually start creating virtual machine disks and associate the virtual machine disk with these containers. You need to have some form of platform that allows you to automatically assign or allocate storage components to the platform itself. And that's exactly where vSAN file services comes into play. Not only is it, of course, available for these cloud native workloads, of course, on top of that, you can also run traditional workloads against these file services capabilities. And of course, you also have the ability to create regular file shares, which can be connected to and by the various customers or clients that you have in your environment. Now, before we start diving a bit more into specifics around what we are planning from a future perspective, I do want to show you what it is that vSAN file services provides you. In this particular environment, we already have vSAN enabled, and we also have vSAN file services enabled. But what I'm going to do is I'm going to click on the interface so you can see what it actually would take to enable vSAN file services. When you go through the interface, there are a couple of simple things that you will need to do. But the most important part here, in my opinion, is that we now have the ability to start connecting vSAN file services, for instance, with Active Directory, so that you can now, on a per user level or group level, specify who has access to a particular file share. Now, of course, before they get access, they will need to have the ability to connect over a network. So in order to provide that ability, vSAN file services will need to be connected to a virtual machine or to a virtual machine port group, which is available within your vSphere platform. And of course, on top of that, you will also need to specify the IP addresses to which you can connect. After you've provided all of that information and vSAN file services has been enabled, you can now start creating these file shares. You can create a file share simply by clicking Add and then providing a name. After you've provided the name, of course, you can select the protocol for which this file share can be used. Today, we can only select a single protocol. In the future, you may be able to select multiple protocols for the exact same file share. Besides that, we can, of course, specify thresholds, but on top of that, we can also define a storage policy. And this storage policy in my particular situation is a RAID 1 configuration, but this could also be a RAID 5 or a RAID 6 configuration. For now, we don't support stretch cluster configurations, but you can imagine that at some point in the future, this is also something that we may be exploring. Not only can you provide or can you create these file shares, of course, you can also connect to these file shares. You can do that by simply clicking or selecting the file share and then clicking the copy path. Or on top of that, you can also copy the MMC command and start looking at, for instance, the security or the permissions that have been set on the file share. Besides connecting to the file share, the ability that vSAN also provides you is monitoring the environment a bit more in depth. So you can see how the data is being placed. And on top of that, you can also see from a performance perspective what is happening. Not just from an overview point of view, but you can also click on View Performance and start diving into vSAN file services a bit more in depth. You can select the time range and then start hovering over the different graphs to figure out what has happened in your environment. Now, as I've already mentioned, not only do we provide a lot of additional insights in terms of performance details, we're also providing a lot of additional insights in terms of what is happening from a capacity standpoint. So from a file share perspective, but also from a container perspective, all of that information is also provided in the UI. I've already briefly mentioned the health check. And of course, with every single new feature, we will also introduce additional health checks, which will immediately tell you what the environment is doing and what is happening. So all of those capabilities are part of vSAN as it is right now. And for those who haven't used it, it's part of vSAN 7.0 Update 1. Another feature which is part of vSAN 7.0 Update 1, which I think is truly unique, is HCI Mesh. Now, HCI Mesh in the UI is referred to as data store sharing. So if you're one of those customers that have already started looking into 7.0 Update 1 and you couldn't find HCI Mesh, then you should be looking for the data store sharing capability within the UI. So what is this HCI Mesh capability? Well, over the past couple of years, when customers started to adopt vSAN, what some of our customers have noticed is that from a sizing perspective, not all clusters should have been created equally. And although from a management perspective, they may have made life a bit easier, of course, from a capacity standpoint, that could result into a situation when one environment is running out of disk space, while the other cluster has sufficient disk space. And this is where HCI Mesh or vSAN data store sharing comes into play, because it basically allows you to start mounting remote data stores. As long as you have a vSAN cluster up and running, you can now mount those remote data stores and actually provision virtual machines as well, or move virtual machines simply from one cluster to the other cluster. And this is the new capability was introduced as part of 7.0 Update 1. Now, I also want to show you what that looks like, because it sounds rather complex mounting vSAN data stores, but it actually isn't complex. And what I think is truly unique about this feature is that if you have an environment where you have, for instance, a hybrid cluster and you have an all-flash configuration, you can start provisioning virtual machines on an all-flash configuration while it's running from a compute perspective in your hybrid environment, simply by mounting that remote all-flash data store. And that's basically what I've done here. I went to the UI, I selected the remote data store, and I said mount, and now automatically all of the hosts within my cluster will get access to that all-flash data store. And of course, now when I provision a virtual machine, I can simply select the data store that I want to provision that virtual machine to. So in this particular case, of course, I'm going to show you that I can provision the virtual machine on an all-flash data store. What is also rather unique, not only can I take advantage of the capability of the fact that it's an all-flash data store, I could potentially also select a storage policy that locally I wouldn't be able to satisfy, but I can satisfy remotely. So locally, I only have 4 hosts, which means that I can't do a RAID 6 configuration, for instance. In this particular scenario, when I select a remote data store, I can do a RAID 6 configuration, because that is what the data store is capable of providing me. And that is something which I feel is truly unique about the vSAN solution. Of course, besides providing you the ability to provision virtual machines efficiently across the data center, on top of that, we will also provide additional monitoring capabilities, so you actually know where virtual machines are being stored, whether that's remotely or whether that is locally. Now, I briefly mentioned this during the session, that you can only use this capability if you have a local vSAN data store available. But of course, we're also planning on making this a lot easier in the future and provide you the ability to start deploying these types of solutions even when you don't have a local vSAN data store. The only thing that will need to happen at that particular point in time is that a vSAN client will need to be configured and installed, and then you can start leveraging a potentially a very storage dense server cluster as well. And the other thing, before we start looking into some of the monitoring capabilities that we've added, that I briefly want to mention, and this is something that we've seen popping up in the industry and something that has been discussed with during VMworld as well, is Smartnix. As you can imagine, as we start exploring all of these different ways of exposing the vSAN data store across clusters, we could potentially start leveraging Smartnix technology as well to load a vSAN client and potentially expose that vSAN data store not only to remote vSAN clusters, but maybe even physical hosts, which are, for instance, running a Linux workloads. So those are all of the different things that we are now exploring from a vSAN perspective. Now, from an operational perspective, there were a couple of things that we've introduced as part of vSAN 7.0 Update 1, which I feel are very useful. The first thing that we've introduced is vSAN IO Insight. And IO Insight basically provides you a lot of detailed information around what a virtual machine or an application is doing. Now, I can of course show you the slide, but what I think is more interesting is show you the demo. So in this particular case, I have a virtual machine running, and what I'm going to do is I'm going to monitor the virtual machine from an IO perspective. So I'm going to go to the vSAN option and click New IO Insight Instance, and then I'm going to select the virtual machine. I can select one or multiple virtual machines, by the way, and of course all of that information will then be presented in UI. As soon as I click Next, I can select the time frame for which this virtual machine will need to be monitored, and after that has been finished, I click Finish, and the IO Insight instance is going to be launched. And after it has been launched, of course, I will need to wait for 10 minutes before I can actually start exploring the data. After those 10 minutes have lapsed, I can go to my cluster level and click on Monitor, and then, of course, I will go to the Performance section. The Performance section will then show me a new interesting piece, which is called IO Insight. And as soon as I click IO Insight, I can now see that instance that I've created, that virtual machine that I monitored. And as soon as I start looking into the metrics, I can quickly see what kind of IO has been produced by this particular virtual machine, how many IOPS it has been doing, what the throughput looked like, whether it's sequential and random IO, and for instance, even if the blocks were aligned or if they were misaligned. And of course, I can also look at the IO size distribution. If the information, for whatever reason, isn't relevant, I can simply rerun this particular batch, or of course, I can delete the information as well. And that is what IO Insight allows us to do. The other thing that we have, or we are planning on introducing, which is something that we are now exploring that hopefully will make your life a lot easier, is IO Trip Analyzer. And IO Trip Analyzer, in my opinion, is going to be a very interesting solution, because besides providing you the ability to specify that a particular virtual machine should be monitored and providing all of the information around what is being monitored, it is also going to provide you the IO path of that particular virtual machine, and of course all of the choking points along that IO path as well. It's going to be informing you about potential latency on the network, maybe latency occurring from a caching perspective or a capacity perspective. All of that information will be presented in the future through the vCenter HTML5 interface. And then last but not least, I do briefly want to touch on this topic. Barry already mentioned it during his session. He already mentioned VMware Site Recovery Manager. And I think VMware Site Recovery Manager is probably one of the most useful solutions from a DR perspective that VMware had launched in the past 10 years or so. But now we are introducing a new DR capability. You may wonder why we are introducing a new capability when we already have Site Recovery Manager available. Well, that is pretty straightforward. A lot of our customers have told us that, first of all, DR is extremely complex and expensive to manage. But not only is it expensive and complex to manage, it's also relatively complex and expensive to configure, especially because it requires typically a secondary or maybe even a third location to be available. And that's exactly what we are trying to solve now through VMware CloudDR. For those who don't know, not too long ago, VMware acquired a company called Datrium, and Datrium already had a DR solution, and this DR solution is now what we refer to as VMware CloudDR, and it basically allows you to replicate your data into object storage and then restore that data into a VMware SDDC, which runs in Amazon. And I think that is something that is truly unique. Now, before someone is going to ask the question on chat later on, I'm pretty sure this question is going to be asked. Will we also support other types of cloud platforms? And which regions are we supporting? Well, first of all, of course, we support the London and Frankfurt region. But more importantly, we're also planning on supporting other cloud platforms in the future, not just for DR capabilities, but of course also for data management capabilities. With that, we've reached the end of my session. I hope you found the session useful. I'm going to hand it over to Frank, and Frank is going to be discussing how to create a developer self-service platform leveraging VMware technology. Have fun, Frank.